Hello everyone. Today we will discuss about the concept of a robot technology. So in this particular concept we will be mainly focusing on the robot anatomy, joints as well as the languages which includes in the anatomy itself, common robot configuration, robot control systems. Then we'll discuss accuracy as well as the repeatability. And these are all the parameter which is considered in robotics, the concept of end effector. Then we'll be implementing different programming methods which is applicable for the performance of a robot, where we have different variety that we're going to study. Finally, we'll be having a industrial application of robots, mainly in different aspects like material handling, processing, assembly, inspection, etc. So we'll discuss one by one. Let us start with the introduction. So now, an industrial robot is a general purpose programmable machine having certain anthropomorphic characteristics like human like characteristics. That means in this particular robot technology we'll be mainly focusing on industrial robots. There are different variety of robot which we're going to consider depending upon the application area. So if I talk about industrial robot here, you will be having the aspects of the programmed machine, which is an improved machine, because robot will going to perform the task depending upon the input what will going to give. According to that, robot is going to perform. It is a improved machine, what we can say. In other words, if you want to describe this robot as, it is a program, means we need to give set of instructions in the form of programs. So what happens, the robot will going to read that instructions what we have already given to the machine, which in the form of a program that will going to execute with the help of the components, whatever the different component we will going to use, like arm, gripper, sensors, etc. What we need to do is we need to study each and every parameter which is considered in robot technology. So in industrial robots, which are mainly used for different operations like assemblies, paintings, welding, material handling, etc. So the plus point of the robot is that it can work in a dangerous environment. This is very important. Why we need to implement the concept of robots? Because in most of the cases where for a normal worker or a laborer, it is very difficult him to work for a longer period, as well as some areas where it is very difficult to work a common man. So in this particular areas we can just replace, instead of using normal workers, if you implement the technology of robot, you'll be getting the better result. So now we'll discuss the actual definition of this particular robot. The Robotics Industrial Association, initially it was called as the Robotics Institution of America, which has given proper definition to the robot. So according to them, an industrial robot is a programmable multifunctional manipulator which is designed to move materials or parts or tools or special devices through variable programmed motion for the performance of variety of tasks. So this is the actual definition which was derived from Robotics Industrial Association America. So they mentioned here, which is a programmable multifunctional manipulator, which is mainly designed to do some work like moving the material from one place to another, moving the part or the tools or the special devices one place to another. How we're going to move this? By giving the instructions. How we will going to give the instruction? We're going to give the instruction or the command in the form of program. Because of that, we'll be using robot, and by using robot we will be performing a variety of tasks. So now we will discuss about the basic components of robots. So the main components, we have derived this component into three categories: manipulator, controller, as well as the power supply. You can see this particular figure where we can see the component, whatever the component we have been considered here: manipulator, controller, as well as the power supply. All these three are interconnected to each other. You can see the basic consideration or the representation here. Initially you will be having the base and the body which is placed on the base will going to give the proper support, and the body consisting of the arm assembly, and this arm assembly consisting of number of links, number of joints, and you will be having the wrist, and at the end the wrist consisting of the end effector. So let us discuss about the advantages of robotics without having any advantage. Simply introducing the concept of robot is waste of time, so there will be a set of advantages we have noticed, so that we have listed here. Initially we can consider this: robotics are mainly used for environmental safety. That is very essential. We mentioned the concept of robot technology which is not harmful to the environment, and which is also suitable for hazardous or uncomfortable working condition. We have already mentioned this. For dangerous places and all, continuous working is highly impossible for a normal worker. So during that time, what alternative solution we can find is we can implement the concept of robots. We can replace robot instead of normal worker. Robot will going to work continuously in this particular hazardous as well as uncomfortable working condition also, and mainly these robots are used to perform repetitive tasks. So repetitive task, the robot is continuously performing. It will not going to find any difficulty, and whatever the input you will going to give, based on that the process will be carried out. So no material usage. Whatever the wastage of the material you are going to encounter in manual method, that will be eliminated, and which will going to operate for a longer period. And this robots can perform the operations with very high accuracy. And also we have already mentioned robots can be performed according to the instruction what you will going to give in the form of programs. So this robots programming what we have, that can be reprogrammed, and whatever the time will be in spending for the inspection, that will be reduced, and whatever the mistakes happens, human error, that will be reduced, and perform multiple tasks. So these are all the major advantages which we have listed out in robot consideration. Now let us talk about the disadvantages. There are different disadvantages that is also noted out as well as pointed out. That is the initial investment. Whatever the investment you will going to pay in the beginning stage, that is very high. Initial investment cost is very high, and robot which is not having its own brain. We mentioned whatever the instruction the instructor is going to give, based on that the robot is going to perform, so cannot make a decision independently, and cannot adopt the changes automatically, and which requires skilled programmer. Obviously which requires skilled programmer, because robot is a improved machine, because we will be implementing the new concept, new technology. So in order to run the new technology or the new concept, you require skilled programmer, and also you require proper maintenance. If you don't maintain it properly, then again that will be a big problem. You will find the difficulty, and also leads to unemployment. This is a major consideration what we can also mention here. The big disadvantages is whatever the work if you assign, it will be performing. So whatever the consideration you have been taken here, whatever the representation we have been considered here, which is directly leads to unemployment. Now we'll go for the classification. This classification, which is mainly made on different aspects, like we have a classification which is based on the physical configuration. Here we have divided this robots into different variety based upon the type of drive systems which we have been used, based on the control systems as well as the dynamic performance, how we can make a classification, and based on the position, how you're going to position or give the position to the robot, where also again you have sub classification, area of application, type of application you will be using, next a type of the controllers, and based upon the types of the end effector as well as the based upon the types of the programming method, we have a different sub classification. In that mainly we are focusing on the physical configuration. So based on the physical configuration, again we have categorized it into four types, starting from polar coordinate configuration system, polar coordinate configuration system, cylindrical coordinate configuration system, Cartesian coordinate configuration system, jointed arm configuration system. So let us discuss one by one. So we will take polar configuration system. You can see the representation over here. Polar configuration uses a telescopic arm that can be raised or lowered about horizontal joint. You can see from the diagram. This robot consists of one linear prismatic joint. Linear prismatic joint is indicated as capital L, a rotational joint is indicated as capital R, and a fixed joint is indicated as capital T, and hence it is called as TRL configuration. Polar configuration system, which we can also implement, or we can also represent this as a TRL configuration system, where we already mentioned L stands for linear prismatic joint, R stands for rotational joint, and T stands for the twist joint. These joints provide the robot with the capacity to move its arm in a spherical space, and hence this robot is sometimes called as spherical coordinate robots. We can also call this polar configuration system as a spherical coordinate robot. The workspace within which the polar configuration robot moves its arm will be spherical in shape. The most of the commercially available robot possesses this type of configuration system. So in the similar way, we'll move on to the another type, where we'll be finding the second case, that is cylindrical coordinate system. So in cylindrical coordinate system, again we need to consider, okay, we'll discuss about the cylindrical coordinate configuration system. So in cylindrical configuration robot, which is consisting of a vertical column and a slide which can be moved up or down along with the column. The robot arm is attached to the slide so that it can move radially with respect to the column. By rotating the column, the robot can be able to achieve the workspace similar as cylinder. That's why you can call this type of configuration system as cylindrical coordinate configuration system. So in cylindrical configuration robot, which is consisting of one twist joint, one orthogonal prismatic joint, and one linear prismatic joint, and hence this is called as a TLO configuration. This is also called as TLO configuration. So this type of robot has a rigid structure with a very high load carrying capacity. A cylindrical configuration robot has very high repeatability with least errors. So this is all about cylindrical configuration system. Now we will discuss about another type, that is Cartesian coordinate configuration system. This Cartesian coordinate configuration system, you can also consider it as LOO configuration system. Here we will be having combination of two orthogonal prismatic joint and one linear prismatic joint. Usually this type of Cartesian coordinate configuration systems which are used for the performance of the work volume of a rectangular block. So similarly we can also have the last type, that is consider it as jointed arm configuration system, and this jointed arm configuration system is similar to human arm. As we can see from the diagram, it consists of two stride components that corresponds to human force arm and upper arm. These components are connected by two rotary joints corresponding to the shoulder and elbow of a human. If wrist will be attached at the end of the arm, the workspace within which this robot can move its arm is irregular. So the jointed arm configuration consisting of no prismatic joint but has two rotary joints and one twist joint, and hence this is also called as TRR configuration system. This type of configuration has higher reach from the base. They are useful in continuous path generation and in application like spray painting as well as welding. So this is all about the different four physical configuration which we have considered in robot technology. Now let us discuss something about the application of industrial robots. So this application we have considered it into different the consideration depending upon the application area. So we can see this mainly considered or differentiated depending upon the material transfer, machine loading, welding, spray coating, processing operation, assembly as well as the inspection. So let us discuss one by one. Now initially we'll consider the material transfer. As the name indicates, material transfer, we need to transfer the material from one place to another, and this work will be done with the help of robots. So we can also call this type of operation as pick and place on operation, transfer of material from one conveyor to another conveyor. You will be finding the application of robot. Very easily we can transfer the material from one conveyor to another. Machine loading, this is a process where a robot is required to supply a raw material to the processing machine and the unload the finished part from the machine. So here also machine loading, what the robot is going to do, what is the main consideration, what application we can find in machine loading that they have been considered here, which requires the supply of raw material. Initially the robot is required to supply the raw material to the processing machine. After that, whatever, once the process is complete, that will going to unload the finished part from the machine. In case of machine loading, the robot works directly with processing equipment, and in case of material transfer function, it will not. So we need to be very particular about this particular consideration. So now in welding, again we mentioned a robot is having different application as well as the advantages. In the advantages we discussed, it is very difficult to work for a normal worker in complicated areas. So as we mentioned here, in welding also we have different variety of welding, either it may be spot welding or arc welding, where you can find this the difficulty. If you consider or if you use a normal worker to work with this particular areas, it is very difficult in that to work for a continuous period of time. So what one alternative solution we can find here is, instead of using normal worker, we can replace instead of worker we can use the help of robots So we can find the application in welding process also. Spray coating, again we can also consider the implementation or the consideration of robots in spray coating, because by implementing this robot we can perform the operation safely, safe operation, as well as lower material usage. Whatever the usage of the material you will going to consider with the consideration of robot, we can reduce it, because whatever the error which is going to encounter by using normal man, that will be eliminated, because of the instruction what you have been given. Depending on the instruction, the robot is going to work. Unless verification is required, also you will be getting the greater productivity. Now let us also consider the application in processing operation. There are performed by, or we can also consider these are performed by a specialized tool which is attached with the help of a robot arm. By using this attachment, you will be performing different variety of operations, and these tools can do lot of operations like drilling, riveting, grinding, polishing, etc. Assembly, if I talk about the assembly, what if in any manufacturing system or production system, whatever the part you have been produced, that you need to assemble it in a sequential manner. So robots are widely used for assembly operations in industries, which may result in increased productivity, one thing. And also robot can do repetitive tasks continuously. It will be doing a repetitive task continuously in case of assembly operation. So this will be a very big what we can consider, this will be a very big task as we compare with the normal man. Inspection. So inspection is also very essential in any production system. This is a new application area of the robot. Previously the inspection process was difficult and very slow because of some complications. Nowadays, as the quality of the product becomes very important, each and every product must be inspected, and this can be accomplished by a robot. So inspection is very very important. Whatever the product you will going to produce to the market, that's supposed to have high quality, so this quality will be inspected with the help of robot very easily. Here robots are equipped with mechanical probes, sensors and other measuring devices to perform inspection process. In order to perform inspection process, there would be a certain devices which is equipped. With the help of this devices, we can perform the inspection process. Now we can have the robot specification. So how you will going to specify a particular robot? So in order to specify a robot, there will be a different consideration, different aspects which we have been listed here. Depending upon the number of axes the robot consisting of, the maximum capacity of the robot, the speed of the robot, the operating environment, in which environment the robot is performing, different performance parameters which we have been taken into consideration, work volume, types of the drive systems. So these are all the specification areas which we have been considered in robot. By taking the all these parameters, you are going to specify the robot specification. Now we'll discuss the performance parameter. This is also very essential in robot technology, where we have segregated three different parameters: spatial resolution, accuracy and repeatability. So let us discuss one by one. If I talk about spatial resolution, it refers to the smallest possible movement which a robot can move in its work volume. So initially we need to define what exactly the meaning of spatial resolution. So by considering this, which is a smallest possible movement which is going to be taking place within the work volume of a robot. And this spatial resolution is mainly depending upon two factors. First one is control resolution and second one is mechanical inaccuracies. So if I talk about control resolution, again it is the capacity of a robot to divide its work volume into smallest possible increments, is called as a control resolution. So whatever the consideration we have been taken where we need to justify it. So in control resolution we can call it as the capacity of a robot. What it will going to do, it will going to divide its work volume into smallest possible increments, and this process or this consideration is called as control resolution. Now let us talk about the inaccuracy, especially mechanical inaccuracies. Obviously we know inaccuracies in the robots, links and joints will have effect on the spatial resolution, and mainly this inaccuracy which is going to happen depending upon different factors like load carrying capacity. If you have certain load carrying capacity, if you extend that, then there will be a inaccuracy. There is a limited speed, if you extend that, again you'll be getting inaccuracies, and there will be some maintenance factor that is also mainly affects the mechanical inaccuracy. There will be interconnection. As we mentioned, mechanical inaccuracies are mainly depending upon the spatial resolution. Now I will discuss the second parameter, that is accuracy. So we can just define it. It is the ability to position the wrist and at a desired target within a robot's work volume is called as accuracy. You can see this indication as well as the representation over here, where we have the consideration of two end effectors, and whatever the distance between the two end effector will be consider it as a resolution, and you need to fix the target point in between, and whatever the distance which you have been considered between one end effector to the target point is represented as the accuracy. So this accuracy will be less when the robot links are in fully extended position. The second consideration what I need to make here is the accuracy will be very less when load carrying capacity is very high and when speed is also very high, inversely proportional. Now let us discuss compare it with the resolution. Higher the resolution, higher the accuracy. The third parameter, that is repeatability. As the name indicates, the ability to position the wrist of the robot at the same point again and again is called as a repeatability. The process as well as the ability of the position of the wrist of the robot at the same point again and again, the same thing is going to happen, is consider it as the repeatability. Now we'll discuss something about robot motion. So industrial robots are designed to perform productive work. We all know that this industrial robot, which is mainly designing for the purpose of doing some productive work. No, so the work is accomplished by enabling the robot to move its body, arm and wrist through a series of motion and position. As we mentioned already, it is a different kind of process, or different, it is a improved machine where we'll be having a human like structures, the machine which consisting a body, which consisting arm as well as wrist, etc. So by using this you will be accomplishing the required task. So the movement of the robots are divided it into two categories, because here you'll be concentrating on the movement as well as the motion of a robot. So this motions are divided it into two considerations. First one is arm motion, we can also call it as a body motion. Second one is a wrist motion, depending upon the consideration which we have taken according to the consideration of arm or a body, then we're going to consider it as arm and body motion. And whatever the movement which is going to be taking place with the consideration of wrist, then we're going to call it as wrist motion. So the another parameter is end effector. In industrial application, most of the work is done by additional devices, and which are called as robot peripherals. We know most of the consideration which will be done by the additional device, and these robot peripherals includes tooling which attaches to the robot wrist. We have already seen the arrangement of the robot, which consisting of base and consisting of body, arm, wrist, links, joints, etc. Correct. So we know in the wrist you will be having a separate parameter or the consideration where you will be fixing the tool, and that particular area which is considered it as an end effector, and this end effector makes a general purpose robot to perform a particular operation. The tooling must be designed specifically for that particular operation, whatever the task depending upon the task what you will going to perform, the tooling must be designed. And if I consider the tools as an effector, in most of the industrial applications, tools are directly attached to the robot's wrist. In this case, tools act as an end effector. Whatever the tool you will be going to use in order to perform the task, then specified tool what you will going to attach, that act as an end effector. We can see the examples here. Spot welding tool, if you use, then it's still going to act as an end effector. Arc welding torch, spray painting nozzle, drilling operation, grinding, water jet cutting tool, heating torch. These are all the tools used as an end effector. Tools as an end effector. Now we'll be in the last part of the robot technology, that is the programming of a robot. This is also very essential as well as very important consideration which we can make in robot technology. So let us define it. Definition: the robot programming can be defined as the path followed by the robot manipulator along with its peripheral to perform a specific task as well as the work. So we mentioned robot is a specified device which will going to perform the task depending upon the input what you have been given in the form of program, as well as the instructions which you have been given in the form of program, right? So the programming is also very essential part in robot technology. So you need to have you need to adopt a different programming method in order to perform the task. There are 4 different types of programming methods through which the robot can going to perform. So these 4 divided methods are: manual method, walkthrough method, we can also call it as manual lead through method. Third one is lead through method. We can also call it as powered lead through method. We can also call it as online method. And the fourth one is offline programming method. So let us discuss one by one, starting from the manual method. As a name indicates, we will be performing manually. This is a method is used only for a small robots, simple operations, or the simple application. You will be performing this type of programming method called manual method. This method involves in setting of the machine rather than the actual programming. Setting of the machining is very essential rather than the actual programming what you are going to feed. This method is mainly employed for low technology robots with short work cycles. Simple method we're going to implement. For example, pick and place robots, you will be using manual method, where what happens, setting up of the machine is very essential as compared with the actual programming. Next we'll go for the second type, where we'll discuss walkthrough method. As we mentioned, this walkthrough method we can also call it as manual lead through method. This method is employed for programming the robot with continuous path controls. Initially we will going to make some arrangement. In this method, the programmer as well as the operators manually move the arms of the robot through a motion sequence. This is very essential. What is going to happen, what is the difference between the first method and this, we need to make out, because we have already mentioned there are 4 different types we're going to implement in programming. So you need to see the differences. In this method, the programmer or the operator will going to operate manually move the arms of the robot initially through a motion sequence. Each movement will be recorded in the memory for a subsequent playback during the production. We mentioned initially the operator will going to move the arm of the robot through a motion sequence. Then the movement what is going to be taking place, what is going to be encountered, will be recorded in the memory. Then this method which is used to program the robots performing for spray painting, arc welding applications. We mentioned manual method will be considering for a simple operation like pick and place operation, but here we have been implemented this for spray painting operation, arc welding application, etc. Next we'll move on to the third method, that is called as lead through method. We already mentioned lead through method. We can also call it as powered lead through method, or we can also consider this as online method. So what happens in this method? In this method, commonly used to perform or commonly which is used to program robots with point to point control. We need to consider point by point a handheld control box called teach pendant. We need to consider handheld control box, and which is called as teach pendant, which is used to drive the robot through its motion sequence. The teach pendant is a small handheld device which consisting of various switches. We need to specify what how the appearance of this particular teach pendant, which is a small handheld device which consisting of various switches and dials to control various movement of the robot. So you need to identify, or you need to highlight one thing, that in lead through method the various movement of the robot will be controlled by a device called teach pendant. Each movement is recorded in robot control memory for future playback. And we need to segregate some of the advantages, or you need to identify some of the disadvantages which is encountered in lead through method. So if I talk about the advantages, this method is relatively easy and simple. One thing we can consider here is this method what you are going to adopt for the programming, which is easy as well as simple. No special programming skill training as well as whatever the trained worker is not required to perform the method. But there will be some disadvantages that also we have been listed here. This method cannot be used for large and heavy robot. This is what the drawback we will be having here. We cannot use this for large as well as heavy robot, and this method require a lot of memory to store the data. This is very important drawback we need to consider here. Whatever the memory you will be using in order to store the data, which is very high, that means you require bigger memory to store the data. The final method, programming method, is considered as offline programming method. So as the name indicates, this type of programming is performed on a computer, and after the program has been prepared, it is entered to a robot memory. It is directly entered to a robot memory. The advantages of such programming is that the production time of the robot will not be lost, one thing, as in case of the other type of programming. So you need to make out the differences. If you identify the difference here, the main identification what we can make is the type of program what we're going to consider, what we're going to perform with the help of computer. Once the instruction is ready, you need to feed this program, or as well as the instruction in the form of program which is to be entered into robot memory. Then here we'll be considering what are the production time of the robot you have been considered, which is less as compared to other type of programming method. And usually where you're going to find this type of offline programming method, this type of programming method can be integrated with various CAD/CAM systems. So this is all about the programming of uh, robot technology. So we have already concentrated on all the aspects. Thank you.